This is our experiment looking at bending moment in a beam. When we apply a force along the course of a beam, we generate a deflection, we generate a bending moment about the ends, and we can use that relationship between the force and the distance from the ends to compute a bending moment and evaluate the response of the structural member to bending. In the case of this demonstration, we have a beam which has some articulating features and is designed so that it can measure the amount of deflection force or bending force that are applied at this split in the beam. So for our first experiment, we're looking at applying force here and looking at the bending force relating to it. The force gauge reads in newtons, and the bending force in this case, for this particular setup, is 1/8 of the force readout in Newton meters. So we start applying force at the cut, starting with 100 grams. Our reading is 0.8 newtons. Record that. Against 100 grams. 100 grams of mass, which is 0.98 newtons. So our force reading is 0.8 newtons, which would be indicative of a bending force or a bending moment of 1/8 of that, or 0.1 Newton meters. So we go to a larger load, go to 200 grams. Apply at the same point. Get a value of 1.5 newtons. And continue with larger and larger loads. In this case, going in with 300 grams or 2.94 newtons. And we get a 2.2 Newton force readout, or 0.275 Newton meters. Go to 400 grams. And our reading is 3 newtons, or 0.375 Newton meters. Go up to 500 grams, and we get a reading of 3.7 newtons, or 0.45 and change Newton meters. Okay, that is our first experiment. We've looked at loading at the cut. I want to look at what happens when we load other places on the beam. The first one we want to look at is if we load outside the the supports that were supported here. These are our two reaction forces. And we want to load this thing to the outside. So we're going 140 millimeters outside that point of support. And my bending moment that I generate is negative 1.4 newtons. Basically, I'm bending upward. Positive moment in this case is downward, and we're bending this thing upward because I'm exerting a force here that pulls this back. I have a moment about this axis and a countervailing moment because of the reaction here. So what we record there is our weight, 3.92 newtons. We don't have a second weight. And the force is negative 1.4 newtons. This is our, so my bending moment is 1/8 of that, or negative 0.175 newton meters. So to compute the theoretical moment, you'll need to compute the reaction for this using static equilibrium. You'll compute in this case, the distant support value based on equal moments about this support, and then use the balance of forces to get this one. Okay, the second one we want to look at is more than one load on that beam. This is figure 5. And I want to have 200 grams and 400 grams at the indicated points. And I want the lesser weight at 220 millimeters from the point of support. I want the larger weight 260 out from the point of support. So my distances are as shown, and I generate a positive moment 3.7, or a force of 3.7 newtons. So that would be a bending force of 1/8 of that, or about 0.46 newton meters, approximately. So our third experiment for this frame I'm going to have forces on both sides of the cut. So I want my two heaviest loads, 400 and 500 pounds, 400 and 500 grams. In this case, I want 500 grams, 240 millimeters off the point of support, which would be here, and the Second load would be 400 millimeters off the point of support, which is almost to the far end. So now I have moment on both sides of the cut. And my force is 3.8 newtons. So I have about 0.475 Newton meters there. So we would again compute the theoretical load based on finding moments about one end to compute the static load from either end, and then that will give you the wherewithal to compute the bending moments from each one.